Alright, let's look at the practice exam 3, problem number 11. Alright, so we want to find the interval of convergence for this given power series. Alright, so let's do that. Alright, I'm going to use the ratio test on here. Ratio test. Alright, so we're going to do a limit as n approaches infinity. Then we have an absolute value here. Alright, so this is going to be our an. Alright, so this is going to be our an. So we would like to have an plus 1. So every time we see n, we put n plus 1. So it's a quantity x minus 1. Then we would put n plus 1 over. Alright, so you have a 2 to the n, so we put 2 to the n plus 1. Alright, then you have a square root of n plus 1. Alright, then this is going to be divided by an. So I'll just take the reciprocal of this and multiply. So you have a 2 to the n, and you have a square root of n, and then you have quantity x minus 1 to the n. Then you have an absolute value sign. Alright, so let's simplify this. So you have, let's see, 2 to the n here, and 2 to the n plus 1. So I'll just scratch that out. So you have a 2 left over. Alright, x minus 1 to the n, and then we scratch this out. Then you have another x minus 1. Alright, so since this one, x minus 1 and the 2, those are just constant because it has nothing to do with n. So what we can do is we can just pull out. You have to make sure to put the absolute value. So absolute value of x minus 1 over, and 2 is already positive, so you don't need the absolute value sign. Right? Then you would have to take the limit as n approaches infinity. Right, the only thing that's left over would be you have square root of n on top and the square root of n plus 1 on the bottom. So since both of these guys have a square root, so I'm going to put it under the same square root. Then you have an n on top. Then you would have n minus 1 on the bottom. Alright, we can easily evaluate this by multiply by top and bottom by 1 over n inside the square root here. So we get this. So you have a constant, absolute value of x minus 1 over 2. And then you have a limit as n approaches infinity of square root, right? So n divided by n is 1, and n divided by n is 1. 1 divided by n is 1 over n. Right? Then you see that as n approaches infinity, 1 over n approaches 0. So this is going to go to 1. So what you get is just simply absolute value of x minus 2. Oh, sorry, not 2. 1. Right? Over 2. Right? So this is a ratio test. So just like the R value in geometric series, so we want this value to be less than 1 to get a convergence. Right? So we multiply both sides by 2 to get absolute value of x minus 1 is less than 2. Alright, then we can get an interval out of this by doing the following. So this is going to be, right, so take away the absolute value sign. So we know that x minus 1 has to be between negative 2 and a positive 2. Right? Then since I want to isolate x, I want to get rid of negative 1. So I'm going to add 1 to every one. So you have a negative 1 is less than x less than 3. Alright, so we're talking about the interval from negative 1 to positive 3. All right, so we need to check both endpoints, so x equals -1 and x equals 3 separately. All right, so let's do when x equals -1. So this is the left endpoint. All right, the series is going to become, so you plug in x equals -1. So you have a summation, n goes from 1 to infinity. All right, so -1 minus 1 is -2, so you have a -2 to the n, and the denominator is exactly the same, so 2 to the n, square root of n. All right, but here, we know that the -2 and 2 can be separated, so this can be written as distribute the nth power to -1, so -1 to the n, and distribute the nth power to 2, so 2 to the n. All right, so you can cancel 2 to the n and 2 to the n here. So what you get is summation n goes from 1 to infinity, and then you have a -1 to the n, right, and over, so I'm going to write it as 1 over square root of n. All right, so we get an alternating series, and we can do the alternating series test to show that this guy actually converges. All right, maybe I should say, so this is going to converge, all right, by alternating series test. All right, so alternating series test, you have to check two things. One, all right, so Bn in this case, so it's a 1 over square root of n. All right, Bn doesn't contain -1 to the n. All right, then if you compare with the Bn plus 1, all right, which is 1 over square root of n plus 1. All right, in this case, it's obvious because numerators are exactly the same. Denominator gets larger, of course the fraction gets smaller. All right, so we have a decreasing sequence here. And 2, and if you take the limit of Bn, which is 1 over square root of n, as n approaches infinity, we have to make sure that this goes to 0. But the 1 divided by square root of infinity is infinity. It's going to be 0. All right, so both conditions check out. So therefore, we know that this series is convergent. So when x equals 1, a -1, series is going to converge. So we want to include -1 in the interval of convergence. All right, how about the other endpoint, which is the right endpoint, x equals 3? So when x equals exactly equal to 3, then this power series becomes summation n goes from 1 to infinity. All right, 3 minus 1 is 2, so you have a 2 to the n over, you have a 2 to the n square root of n. So we can cancel n square, 2 to the n, 2 to the n. We get that this series, this is going to be a p series. So you have n goes from 1 to infinity, 1 over, right? I don't like square roots, so I'm going to write it as n to the 1/2 power. All right, this guy actually diverges. We know that the by, this is a p series test, right? I keep on writing S for p. So p series test with p value in this case is 1/2, which is less than or equal to 1. So we get a divergence. All right, so therefore, interval of convergence is going to be -1, we get a convergence. So we put a square bracket to indicate that we're going to include -1. And to 3, and we put the right parenthesis to indicate that we do not want to include +3 because we get a divergence there. All right, so that's the interval of convergence. So be sure to check the endpoints, and so that we can determine whether or not we should include the left endpoint and the right endpoint. All right, that's it. I hope that this was clear.